Alright, today we're going to begin doing some word problems using systems of equations. Today's only word problems are like with the wind and against the wind and with the current and against the current. So here's some steps you guys can follow as you're working through these word problems. The first thing we're always going to do is we're going to find the two unknowns. There's going to be, you can write them as x and y. A lot of times I'm going to use different variables just so I can abbreviate the actual word, like a rate I might use R, or current I might use C instead of X and Y. Then what we're going to do is we're going to set up we're going to set up the two equations, and then we'll solve the system either using substitution or elimination. And then we'll make sure that we've answered the question that's being asked of us. I am going to end up using elimination most of the time. Because that's the way I know the majority of the students are solving those, but understand that you could use substitution as well. When you're traveling, there's an airspeed or rate, okay, and so these are the types of abbreviations I'm going to use. I'm going to use rate for how fast the airplane's going, and then I'll use W for the wind speed. I'll use C for current, when we're talking about traveling up a river and that kind of things. The two formulas you need to make sure that you understand is that tailwind means that you're actually gaining speed because it's the airplane speed plus the wind itself. Headwind means that you're traveling against the wind, so the wind is actually slowing you down, and so you end up subtracting off your wind speed. I definitely like to use this distance equals rate times time equation when I'm setting up my problems. I also like to do it in form of a chart. So what I would suggest doing on these particular problems when you are talking about rates is going ahead and creating a chart and labeling it up here, distance equals rate times time. That's a formula that we're going to hear over and over. You might as well just learn it. What you then can do is fill this chart in. We'll have distance, and we'll have rate, and then we'll have our time. What we have going in over here would be, it says Anne can paddle her canoe 15 miles downstream in 2 hours. The return trip upstream takes 3 times as long. So we've got downstream, and we've got upstream. Either way, it's still the same distance. It's 15 miles she's traveling downstream, and it's also 15 miles that she's traveling upstream. Her rate is the unknown, and we'll deal with that in a little bit. What we want to also talk about is the time. So when she goes downstream, it only takes her 2 hours, and I always like to fill in the time before I fill in the rate. It makes things a little easier for me, and I'm not memorizing. I'm thinking logically about it. The return trip takes 3 times as long. 3 times as long would mean instead of 2 hours, it would take her 6 hours. So what we're going to now do is think about this. If we have some sort of rate here, and we have a current, on both of these we have a rate and a current. Would I add the current speed? Would this make sense? That's what I want to ask myself. Would this make sense? Would I add current speed and it take more time? No, it wouldn't take more time if I was adding on some sort of speed. It would take more time if I had to go upstream and I was going against the current. And it'd take less time, so I'd be using the current rate if I was going downstream. So I'd have the rate of my boat plus the current. So now I can go ahead and set my problems. I've got distance equals my rate times my time. And then my other one is distance equals rate times the time. So this is not the typical way we are used to seeing these problems. So what I'm going to actually do is I'm going to rewrite these off to the side as 15 equals 2 times R plus C. And then here I'll do 15 equals 6 times R minus C. I will then solve the system in the next video.